Let's talk about mass spring systems, a cool application of differential equations. A spring is stretched 0.1 meters by a force of 4.8 newtons. That's about 1.08 pounds. A body with mass 3 kilograms is attached to this spring. Find a general equation for the resulting motion. Well, here's a principle that's helpful. If we have an object with mass m attached to a spring with spring constant k, and the damping constant for the system is b, then the position y of t of the object satisfies the differential equation my double prime plus by prime plus ky equals 0. This is called free motion. There's no outside force acting on the object. If there were an outside force, this would be something other than 0. But since it's 0, we know there's no outside force acting on the object. We're told that m is 3 kilograms, k, the spring constant. Let's calculate that. So here's Hooke's law, F equals ky, okay? So F is the force applied to the spring, K is the spring constant. In this case, the force applied to the spring was 4.8, remember? 4.8 newtons, we saw that, okay? And then K, the spring constant, we know. So this, Y, that's the distance that it moves. So if 4.8 newtons will stretch at 0.1 meters, that means that F equals 4.8, Y is 0.1, so K is going to be 4.8 divided by 0.1, in other words, 48. 48 newtons per meter. That's the spring constant. Okay, so we have m equals 3, K equals 48, B equals 0 because there's no damping, nothing slowing it down, so it's undamped free motion. Something that damps motion would be a shock absorber, maybe motion through water, something like that. These are things that slow it down. Okay, so B is 0. That means we don't even have this term here. So it's my double prime plus ky equals 0. In other words, 3y double prime plus 48y equals 0. So that's the differential equation for the motion. Let's solve this. First, we can divide everything by 3 and get y double prime plus 16y equals 0. Therefore, r squared plus 16 equals 0. R equals plus or minus 4i. Remember that? Remember how to calculate. Remember how to work with complex numbers. Hope you do. So you would just move the 16 to the other side, and then you'd have r squared equals negative 16, so r equals plus or minus 4i. So r equals plus or minus 4i. In other words, it's going to be 0 plus or minus 4i. So y is going to be of the form k1 cosine 4t plus k2 sine 4t. Another way to solve the problem, undamped free motion y of t satisfies the differential equation my double prime plus ky equals 0. The solution will always be, so again, if you have a differential equation of this form, undamped free motion, the solution will always be y equals a cosine omega t. I know it looks like a w, it's not, and it's an omega. A cosine w, I'm sorry, now I'm messing up. Y equals a cosine omega t plus b sine omega t, where omega is the square root of k over m. For example, in our case, omega is the square root of 48 over 3, it's k over m, which is the square root of 16, which is 4. And thus the solution is a cosine 4t plus b sine 4t. So a slightly quicker way to obtain the same result. Okay, here I've got a and b. There I had k1 and k2. Same difference. Find the equation of motion y of t if the spring is set in motion with initial position y0 equals 0.3 meters and initial velocity v0 equals negative 1.6 meters per second. Okay, so we know y of t, the equation of motion, the general equation looks like this. Therefore, when t equals 0, we'll plug in t equals 0 because we know what initial velocity and initial position are. Y of 0 is going to be 0.3. Okay, that we were told. Y of 0 is 0.3. And y prime of 0 is negative 1.6. But we know what y of 0 is. When you plug in 0 into this equation, you end up with y of 0 equals k1. And that's going to be 0.3. So we know that k1 is 0.3. And again, that's because when you plug in t equals 0, sine of 0 is 0. So that's just going to be nothing. And when you plug in t equals 0, cosine 4t is just going to be 1. So we end up with y of 0 equals k1. That's where this comes from. And we know that y of 0 also equals 0.3. So that means k1 equals 0.3. Okay, y prime, let's take the derivative. Y prime is going to be negative 4k1 sine 4t plus 4k2 cosine 4t Plug in 0. Okay, when you plug in 0, this stuff's just gone because sine 0 is 0. And we're left with 4k2 cosine 0 is negative 1.6. Again, the negative 1.6 came from here. Divide both sides. Okay, cosine 0 is just going to be 1. So we have 4k2 equals negative 1.6. k2 equals negative 0.4. So y of t equals 0.3 cosine 4t minus 0.4 sine 4t. That's the solution to this initial value problem. Again, that's because k1 is 0.3 and k2 is negative 0.4. Find the period, frequency, and amplitude of the resulting motion. Okay, undamped free motion, again, satisfies a differential equation like this. We've seen before what the solution is. A cosine omega t plus b sine omega t, where omega is square root of k over m. The period is going to be 2 pi over omega. Where does that come from? We learned that in pre-calculus years ago. We saw that if you have a function a cosine omega t, well, if you just said cosine t, that is period 2 pi. Cosine omega t has period 2 pi over omega, and ditto with cosine omega t plus, a cosine omega t plus b sine omega t. So the period's 2 pi over omega, which is 2 pi over 4, pi over 2, which means the frequency will be the reciprocal, omega over 2 pi. Because if the period is pi over 2, that means the length of one cycle is pi over 2, which means the number of cycles per second or per unit time is the reciprocal of that, namely 2 over pi. 2 over pi cycles per unit time. Okay, so let's graph this function and see if we can figure out what the amplitude is. We found the period, we found the frequency. This is what it looks like. Looks like the amplitude is 0.5. And actually, it is 0.5 because the amplitude of y equals a cosine omega t plus b sine omega t is the square root of a squared plus b squared. So here, the square root of a squared plus b squared is the square root of 0.3 squared plus negative 0.4 squared. In other words, 0.09 plus 0.16, square root of 0.25, which is 0.5. So that is indeed the amplitude, 0.5. Determine the number of complete cycles the object will have completed at the end of 10 pi seconds. Well, the period, as we've seen before, is pi over 2. This is the length of one complete cycle. So if you're traveling 10 pi units, you'll be able to complete this many cycles. 10 pi divided by pi over 2, that's 10 pi times 2 over pi. In other words, 20 complete cycles. This is what we call simple harmonic motion. So this undamped free motion, it's also called simple harmonic motion because it moves back and forth, unhindered ad infinitum. An object weighing 9 pounds is attached to a spring with spring constant 16 feet. You don't need the is there. That's grammatically incorrect. That bugs me. Find the period of simple harmonic motion. We've seen this before. Omega, since it's free, undamped motion, no damping here. It's free. There's no force acting on it. Omega is square root of k over m, which in this case is square root of 16 over 9. So here we're dealing with pounds and feet. Yeah, I know it's kind of awkward, kind of antiquated actually, but that's okay. Life goes on. So we have square root of 16 over 9, 4/3. So the frequency is going to be omega over 2 pi, which is 4/3 over 2 pi. That's the same thing as 4/3 times 1 over 2 pi. That's 4 over 6 pi. In other words, 2 over 3 pi. That's the frequency.